Hello students, in this video I am going to solve some determinants problems using determinants property. This solution will encourage you to solve the problems. So see the solutions one by one. Today's first question on the screen. Using the property and without expanding, prove that this determinant equals to 0. Let's solve it. Let delta equal to 0, a minus b minus a 0 minus c, b c 0. Now multiply each of the rows by minus 1. 0 minus a, b, a 0, c minus b minus c 0. I multiply the first row by minus sign, so I put minus 1 left side in order to balance up. For the second row another negative sign, so another minus 1. For the third row another negative sign, so another minus 1. Now minus 0 minus a b a 0 c minus b minus c 0. Now if we interchange rows into columns, 0 minus a b, this row, this column. First row changes into first column, second row 0 c, and third row changes into third column, minus b minus c 0. Now look, this determinant exactly equal to the determinant given here, so we can put minus delta. As we assumed delta equals to this, so we can put here delta, which implies delta plus delta equals to 0, that is 2 delta equals to 0, that means delta equal to 0. Proved. We should write here within the bracket interchanging rows into columns. Because first property says if we interchange rows into columns of a determinant, its numerical value will not be changed. That's why we interchange these rows into columns. Question number 2 on the screen. By using property, show that this determinant a minus b into b minus c into c minus a. The answer is not in the determinant form. So in this case we are not only use the property but also expand at the last stage. Let's see how to solve it. LHS when you go through some mathematical problems, you need some observation. Here the factors are a minus b, b minus c and c minus a. So I will do some row operation. 1 minus 1 a minus b, a square minus b square 1 minus 1 b minus c b square minus c square 1 c square. What I am doing here, r1 prime change to r1 minus r2. What does it mean? r1 prime means new r1 formed by subtracting the second row from the first one. Look, this is the first row, this is the second row. I have subtracted the second row from the first row. So 1 minus 1 a minus b a square minus b square, and new second row, that is r2 prime, formed by r2 minus r3, that is subtracting the third row from the second one, we got the second row. Now 0 0 1 a minus b b minus c c a plus b into a minus b b plus c b minus c c square. I am taking common a minus b from the first row and b minus c from the second row, because in case of 0 we can consider it 0 into a minus b, so we can take common a minus b from the first row and b minus c from the second row. A minus b b minus c 0 1 a plus b 0 1 b plus c 1 c square. Third row remain unchanged. Now I will do another determinant operation. Zero 1 minus 1 a plus b minus c 0 1 b plus c 1 c square. What I did here, r1 prime, that means new r1 formed by r1 minus r2, subtracting the second row from the first one. A minus b b minus c 0 0 1 0 a minus c 1 b plus c c square. Now I can take a common a minus c from the first row. A minus c, so 0 0 1 0 1 c 1 b plus c 0 1 b plus c c square. In order to get the final value, we have to expanding r1. So 0 into 1 c b plus c c square minus 0 into out 0 1 b plus c c square next plus 1 into this row suppress, this row suppress, 0 1 1 C. It is not required to show this because there is 0, there is 0, so we get nothing from these two. The third one is 1 into 0 minus of 1, that is minus 1. I forgot to write here. We write all the three terms, a minus b into b minus c into a minus c. So a minus b, b minus c, a minus c, a minus b, b minus c, and a minus c into minus 1. If we multiply minus 1 with the third term, a minus b into b minus c into c minus a, so we got the ultimate result, which is equal to right hand side. I think you understood this problem. If you can't understand, see the video once again. Question number 3 is on the screen. By using property, prove that this determinant equal to this one. First, write down the question on the copy, then see the solution. It is not that you always understand the solution by single watching. So if you couldn't understand the solution, then see it once again, then it will be clear. LHS x y z x square y square z square yz zx xy. You have to predict what to do by viewing these results. I can take a common from the first row if I subtract the second row from the first one. So x minus y, x square minus y square, yz minus zx, and the new second row I am forming by subtracting the third row from the second one, that is y minus z, y square minus z square, zx minus xy, z square xy. So what I have done here, r1 prime, that is new r1 equals to r1 minus r2. New r1 means this one, and r1 means this one, r2 means this one. So new r1 is formed by old r1 minus old r2, and new r2 made up of r2 minus r3. This is new r2, that is r2 prime made up of subtracting the third row from the second one. I am taking common minus z, so x minus y, y minus z, y plus z into y minus z, minus x, I am taking common minus x, so y minus z, z, z square xy. I am taking common x minus y from the first row and y minus z from the second row. Remaining part is 1 z, x plus y, y plus z, z square minus z minus x, xy. Now subtracting second row from the first one, we get 0, x minus z, here also x minus z, 1, y plus z minus x, z, z square xy. Which operation I did here? R1 prime changed to R1 minus R2. New R1 formed by subtracting the second row from the first one. Now I am taking common x minus z from the first row. 0, 1 z, 1 y plus z, z square, 1 minus x, xy. In order to get the final result, I have to expand this determinant, expanding with respect to R1. So 0 into this row subtract this column subtract y plus z, z square minus x, xy, minus 1 into this row subtract this column subtract 1 z minus x, xy. Next 1, this element 1 z, y plus z, z square. This is equals to 0, so minus 1 into this cross this xy, minus of this cross this means plus xz, plus 1 into z square minus of yz minus z square. Z square cancel, so minus xy minus xz minus yz. If we take common minus 1, then xy plus xz plus yz. I did the same mistake here. I should put a second bracket and write these three factors outside. Y minus z. I am not writing this part in this line, also writing only the last line, x minus y, y minus z and x minus z. So multiplying this third factor with negative sign, we get x minus y, y minus z, z minus x into xy plus yz plus zx, which is equal to right hand side. On the screen, another beautiful sum for you. Using property, prove that this one equal to a plus b plus c whole cube. So a minus b minus c, 2b, 2c, 2a, b minus c minus a, 2c. Now I will do the column operation for this sum. I am subtracting the second column from the first column to get the new first column. So 2b minus b plus c plus a, here 0. 2a minus 2a results in 0. b minus c minus a minus 2b, 2c minus c plus a plus b, 2a, 2b, c minus a minus b. Here I got the first column by subtracting the second column from the first one, and second column by subtracting the third column from the second one, and third column remain unchanged. Minus of a plus b plus c, a plus b plus c, 0, 0, minus of a plus b plus c, so a plus b plus c, 2a, 2b, c minus a minus b. Now I am taking common a plus b plus c from the first column and second column also. So a plus b plus c from the first column and from the second column also a plus b plus c. So we can write a plus b plus c whole square. Now minus 1, 1, 0, 0, minus 1, 1, and 2a, 2b, c minus a minus b. Now I will expand this determinant to get the final result. Minus 1 into minus 0 into this column, this row suppress, 1 0, 2b, c minus a minus b, and next 2a, 1 0, minus 1 1, a plus b plus c whole square, minus 1 into minus c plus a plus b minus 2b. There is 0, so whole part is 0, plus 2a into 1 minus 0, a plus b plus c whole square, c minus a minus b plus 2b, and here plus 2a. Here minus a plus 2a equal to a minus b plus 2b equal to b and c. So we got ultimately a plus b plus c, and we can write a plus b plus c whole cube. That's all. Now try this kind of sums at home. I wish you all the best.